Okay, guys, we're starting our new unit today, and we are going to be talking about matrices. And yes, matrices is the plural of matrix, kind of like the movie, because what they talked about in the movie really is an actual matrix. So matrices is the plural. And it is used actually in a lot of places, including computer programming, designing video games, and things like that. And we'll hopefully be able to see that as we go through this unit. So for those of you who are really into computer games or like working with computers and doing the programming, this is something that you'll actually see quite a lot of. Okay, so the words to know. A matrix is just an array, and it's actually called an array, of numbers, and it's used to organize, and it has rows and columns. And something you need to remember is that columns for a matrix are vertical, just like columns on a house. Okay? You know, if you have a column on your front porch. And rows are horizontal. So rows are horizontal, columns are vertical. And by the way, since you're watching this individually, go ahead, pause it however long you need to, however many times you need to, go back, watch it again, do whatever you need to do so that you can take all the notes, that way you can get everything down. Okay, elements are the individual numbers in a matrix. Okay, so these are all vocabulary words that you need to know so that when we start talking about them, you're like, oh, what is that? Well, now you know. The dimension is literally the number of rows and columns, and yes, it goes in that order, rows by columns, so you count up the number of horizontal rows first, and then you count the number of vertical columns. Scalar multiplication is basically the distributive property for matrices. You take and multiply an entire matrix by a single number. So all the numbers in the matrix by a specific number. And the number could be a fraction, it could be negative, whatever it is, but that's scalar multiplication. So basically it's the distributive property. When you did distributive property before, you would take something like this, and you would multiply the 5 times every single piece. Same thing for the matrices. That last one was supposed to go all the way to the 3, and it didn't. All the way. Okay. So that's what scalar multiplication is. So today and tomorrow you are going to be learning how to write matrices to show real-world problems or real-world data. You're going to learn how to tell what size the matrix is, so you'll be discussing dimensions. You'll be picking out elements and talking about what they mean. And then you're going to learn how to add, subtract, and scalar multiply them. Okay, so let's jump in. And I'll show you what different examples of matrices. And this is just thing from YouTube, just a little flash from the Matrix movie. What they're talking about as far as the Matrix are all these sets of numbers that are going across. Well, apparently it's not going to play it for me, so never mind. And that's the actual code just going down the screen. That's all it's doing. Let's see if this one will play. There you go. That's literally just the matrix right there. These are all numbers. That's all you see is just numbers. And that matrix, if you've ever watched the movie, is basically everything. It's people, it's houses, it's rain, it's streets, it's cars. It's basically the creation of everything. And those of you who like to play video games, all of those backgrounds and characters and all that, it's basically created by this set of numbers. Okay, so if this one will play, I'm hoping this one will play, this is kind of a demonstration on how we write matrices to represent things. Hmm. There we go.
Zlatan then passes the ball to Messi, and then Messi passes the ball back to Zlatan, and many such passes are exchanged. Now it was pretty easy for me to explain this to you diagrammatically. But what if I wanted to explain this to a computer? The computer will not understand diagrams. So we make a small table on the right with 3 rows and 3 columns. We can have Ronaldo, Messi and Zlatan as rows. And to know who the ball was passed to, we have Ronaldo, Messi and Zlatan as columns. We all know what Zlatan is capable of, but let's assume the players can't pass the ball to themselves. So these 3 elements will be 0. There is one arrow going from R towards M, so we write a 1 here, and there's just one pass from Ronaldo to Zlatan. Similarly, we fill the rest of the slots. What we see here is nothing but a matrix. It is nothing but an array of elements, something which a computer can decode. And it summarizes the entire warm-up session. Adding up all the numbers here will give us the total number of passes, and it also tells us the direction of the passes. Don't you wish matrices were taught like this in school?
Okay, so basically it's just a computer can't see the people. It can't see, like in the Matrix movie, it can't see the people. All it can see is the code, and it uses the code to create like the characters in a video game, and it can even make them move by applying some transformations to the matrices, which is something that you'll be doing. Okay, so let's talk about how we write them, because you will be writing them on your paper. Okay, so first off, you give them capital letters. Okay, that's sort of like the angles on a triangle, what we've been doing for the last 9 weeks. You have to give them a capital letter for the name, and you describe them by giving their dimensions. And remember what I said about dimensions, you have to give them in a correct order. It must be rows by columns. You have to give the rows first, horizontal rows, by vertical columns. Okay, so let's take a look at these two. We'll talk about what their dimensions are. So this first one, and again, rows first, rows go across, has 2 horizontal rows and 3 vertical columns. So this is a 2 by 3 matrix, and we'll call that matrix A. Sometimes you will see this written like this. Gives you the capital letter A and gives the dimensions as the small numbers down here so that you know rows and columns. All right, what about the next one? We'll call this one B, and let's describe B. B is a 2 by 1. 2 horizontal rows, 1 vertical column. Okay, something else I want to make sure you get in your notes, very, very important. We have a general form of a matrix, because basically what happens is that we fill in by letters going across and by numbers going down. Okay, so basically in the general form, if I were to add another vertical column here, it would be C1 and C2. If I added another horizontal row down here, it would be A3 and B3. Okay, so numbers go down and letters go across. And we use this when we're going to do some like basic formulas in here. And I want to make sure you understand what the basic matrix looks like, so that when we start telling you, when I tell you to multiply A1 times B2, you'll know what I'm talking about. Okay, so that's the general form that you will normally see if we don't put any numbers in it. Okay, again, what I want you to get out of this is name them, make sure you give rows by columns in that order. Really neat part that we can actually do is we can talk about elements in the matrix. Okay, so as an example, we'll call this one matrix C. Okay, and as you can see, matrix C is a 3 by 4 matrix. 3 horizontal rows, 4 vertical columns. Okay, so it would be 3, 4. If I asked you what C23 is, if I wanted to know what this element was, you should be able to pick out a specific element from a matrix. So I'm looking at matrix C, and I want row 2, column 3. I want the number that is in row 2, column 3. And the answer is 3. This one right here. Okay? You should be able to talk about these, because when we write a matrix to represent something in the real world, well, they're going to ask you, what does this element mean? And you need to be able to tell me what it means in the real world. Okay? So you should be able to pick out pieces. Try another one. How about C31? Hope you got -2, because that would be element row 3, column 1. Okay, so let's actually write some matrices based on some real-world data. And this is going to prove really important for the project that you're going to be doing over the weekend. I have a short quiz grade project based on writing, adding, and subtracting matrices. So this can be very, very important as far as how we write them. Okay, so the baseball team, hey out there to my baseball guys, is selling t-shirts, sweatshirts, and hats to raise money. One player sold 12 shirts, 8 sweatshirts, and 20 hats. Another player sold 14 shirts, 2 sweatshirts, and 12 hats. So we're going to write a matrix to represent. Okay, so we're going to say player A. I'm going to say player B. And you can write these horizontally or vertically. You need to write both of them in the same direction, though. So this will either be 3 pieces going over with shirt, sweatshirt, hat, or 3 pieces going down, shirt, sweatshirt, hat. Your choice. Okay, so 12 shirts, I'm going to write them out horizontally, and 20 hats. So shirt, sweatshirt, hat. Right, and that is player A. And player B's matrix would be 14, 2, and 12. And tomorrow we'll actually start getting into adding these. It's very, very easy. They're just added piece to piece. And then you could actually find the combined total of these 2 players, or even a whole team, by doing this and putting the numbers in a matrix. For those of you who work with Excel spreadsheets, sometimes this is close to it. All right, and again, reminder, you can pause this, rewind it, go back to it, do whatever you need to do so that you're getting all the notes and you're understanding what you need to do. Okay, so another example, this is their stock of candles. For those of you who've never been in Earthbound, they sell a whole bunch of stuff. So I'm going to say that they have blue, purple, green, red, and yellow candles in small, medium, and large. So we're going to write a 2, 3, 4, 5, 6, 5 by 3 matrix to represent their whole stock of all their candles. Okay, so blue, purple, green, red, yellow, and they're just labeled so that we know what the rows and columns mean. Small, medium, and large. All right, so let's say today in stock they have 7 small blue candles, medium, large, and we're just going to fill it in. All right, so we're just going to fill it in. And then we can talk about how many candles they have left. And when we start into adding and subtracting, it's actually pretty cool, because if this is how many candles they have and somebody puts in a really big order, you can then subtract another matrix and show what they have left. And you can do it all at one time because you're writing the matrix. So as you can see, there are no small purple candles and no large red ones, so those are probably really popular. And there's only one medium green candle left, right? And this is just being able to talk about the elements. It's the same thing. Okay, so just being able to write the numbers from data. And again, this would go into a computer, and this is how you would put it in the computer so the computer could keep track of inventory. Very, very important if you ever plan on owning your own business. Okay, so the first set of work that you have to do in Google Classroom, there's 2 pages. One of them has to do with stating what size the matrices are, and the other one has to do with stating the elements, giving the element when you're asked for it. Okay, and so this short video is done, and then you're going to have another short video on adding and subtracting and scalar multiplying them, and then you can start your project tomorrow in class if you want, rather than waiting for the weekend. So if you get both of these assignments done in Google Classroom today, you'll be able to start your project tomorrow, and then when we come back, we'll talk about how we can use this to make shapes. So